Hello everyone, I am Pawan Teja. I am from CSE department. Today I am going to explain an important topic in chemistry. The topic is principles and applications of NMR spectroscopy. What is NMR spectroscopy? It means nuclear magnetic resonance. NMR spectroscopy is an analytical technique used to determine the molecular structure and purity of a sample. Core mechanism. It relies on the magnetic properties of certain atomic nuclei. When placed in a strong magnetic field and irradiated with radio waves, these nuclei resonate at specific frequencies. The fundamental principle: nuclear spin. Spin quantum number. Nuclei must have a non-zero spin to be NMR active. This occurs in atoms with an odd number of protons and or neutrons. Common NMR nuclei. Proton. Most common spin. Carbon. Vital for organic frameworks. Phosphorus. Used in bioenergetics. The resonance phenomenon. G1 effect. In a magnetic field B0, nuclear spin states split into lower alpha and higher beta energy levels. Resonance condition. Absorption occurs when the radio wave frequencies matches the energy gap. This frequency is known as the Larmor frequency. V0 is equals to gamma B0 by 2 pi, where gamma is the gyromagnetic ratio and beta is the magnetic field strength. Instrumentation. Superconducting magnet generates a powerful, stable and homogeneous magnetic field. RF transmitter delivers short pulses of radio frequency energy to excite the nuclei. Probe hold the sample tube within the magnet center and contains coils for transmitting RF and detecting the signal. Computer process the free induction decay signal via Fourier transform into a spectrum. The NMR spectrum, chemical shift, shielding. Electrons surrounding the nucleus oppose the external field. High electron density shield the nucleus, shifting signals upfield, lower ppm. The scale ppm, measured in parts per million, relative to a reference standard, usually TMS tetramethylation, set at 0 ppm. Deshielding, electronegative groups pull electrons away, deshielding the nucleus. Signal shift downfield, higher ppm. Spin-spin coupling splitting. The N+1 rule. Nuclei influence each other's magnetic environment. A signal is split into N+1 peaks, where N is the number of neighboring protons. Key patterns: singlet, no neighbors; doublet, one neighbor; triplet, two neighbors; quadruplet, three neighbors. Applications in chemistry. Structure elucidation. NMR is the gold standard for identifying organic compounds. It reveals the carbon skeleton and hydrogen environments. Reaction monitoring. Chemists use NMR to track reaction progress by observing the disappearance of reactants and the appearance of product peaks over time. Medical application MRI. Magnetic resonance imaging is a direct application of NMR principles to medicine. Soft tissues contrast. Unlike X-rays, MRI excels at imaging water-rich soft tissues like the brain, heart, and muscles. Non-invasive. It uses magnetic fields and radio waves instead of ionizing radiation like CT scans, making it safer for repeated use. Biology and metabolomics. Protein structure. NMR can determine the 3D structure of proteins in solution, providing insights into conformational dynamics that X-ray crystallography might miss. Metabolomics. Analysis of biological fluids, urine, plasma via NMR helps identifying metabolic fingerprints of diseases, aiding in early diagnosis and personalized medicine. Advantages and limitations. Advantages. Non-destructive technique provides incredibly detailed structural information. Quantitative analysis is straightforward. Limitations. Lower sensitivity compared to mass spectrometry. Instrumentation is expensive and requires cryogens. Analysis of very large molecules greater than 30 kDa is complex. Thank you.